One day, a coworker walked into my office and said, "Hey, you want to see something really weird?" I looked up and said, "Well, unless that's a mirror behind your back, I think you already know the answer to that question. Come on, show me." He asked, "You know how you feel like a big winner when a slot machine comes up with all sevens?" "No, I actually wouldn't know what that feeling was like," I replied. He then plopped down a piece of paper with the following equation. What do you think the answer is to this equation? I studied it and started doing the mental calculations when he interrupted. "It's 37. "Okay." Then he said, "You know how 8 is a lucky number in China and East Asia, right?" And then he plopped down another piece of paper with a different equation. "Then what do you think the answer is to this one?" Again, I started doing the mental calculations, and he again interrupted. "It's 37. 37. "Huh," I said. "You had my interest, but now you've got my full attention." He added, "Remember that Veritasium video that we saw a couple months ago about the number 37? Don't worry, the links are in the show notes below, by the way. There's even an entire website dedicated to the number 37 and all the weird and wonderful places that it surprisingly appears." "That's really weird," I replied. "Definitely something is afoot." Then we wondered, does the pattern hold more widely? We just saw that the equation holds for starting values 7 and 8, where the answer is consistently equal to 37. But what about other values? Does it work for 1? Check. Does it work for 2? Yep. How about 3? Bingo. 4? Yep. 5? Check. 6? Yep. We already know it holds for 7 and 8. How about 9? Still yes. Pretty incredible. Interestingly, however, it does not work for the starting values 10 and above, but more about that later. So why does this keep happening? Why is the answer always 37? In the rest of the video, I'll work through our thinking on this solution, but perhaps you have a different approach. Let us know in the comments below. If you'd like to try to figure it out for yourself, pause the video now. Welcome back. Did you figure it out? Did you even actually try? Okay, I'll tell you the answer, but it might ruin it for you. It's actually kind of fun, but you'll get another chance later. Consider what is really happening here in the equation, where the starting value n is an integer ranging from 1 to 9. The numerator of the fraction isn't really n. It's a number written in place value format, also known as positional notation. The leftmost n is in the hundreds place, so it should really read n times 100. The middle n is in the tens place, so it should be multiplied times 10. And finally, the rightmost n is in the units place. As a result, the numerator is actually 100 times n plus 10 times n plus 1 times n. This, of course, simplifies to just 111n. In the denominator, the n plus n simplifies to 3n. The n's in the numerator and the denominator cancel each other out, leaving a fraction of 111 thirds, which of course is simply just 37. The integer value of n didn't even matter at all. It was all an illusion. This also highlights the importance of simplifying fractions. For example, there's an infinite number of ways to represent the fraction 1/2, with 1/2 being the most easily recognizable. While exploring this mystery, my coworker and I dove down a number of rabbit holes, and in one of those holes, we actually found buried treasure. We stumbled across a paper by former mathematics professor Inder Jeet Taneja, and I apologize in advance for probably butchering his name. The paper in question is titled Single Letter Representation of Natural Numbers, Palindromic Symmetries, and Number Patterns. Quite a mouthful. In the paper, he exhaustively describes how to write all the values ranging from 0 to 3000 using an equation with just a single integer input, ranging from 1 to 9 as a starting value, and only using addition, subtraction, multiplication, and division. He's also apparently a frequent contributor to several mathematical websites, listed in the show notes below. If you look inside the paper and scroll to the section on single letter representation, look for the value 37, and you'll find an equation very similar to the one used here. Professor Taneja, we salute you. Well done, sir. Remember earlier when I said the pattern doesn't hold for integers 10 and greater? Well, here's where it gets interesting. For example, start with the value 10. The result is 3,367, which is very obviously not 37. But I think it's interesting that the digits 37 appear in the answer. This pattern, however, consistently holds for all starting integers ranging from 10 to 99. Given the previously solved example, can you figure out why the answer is always 3,367 for the integers ranging from 10 to 99? If there's enough interest, maybe I'll do a follow-up video that works through the example. Please let me know in the comments below. If you enjoyed this video, please click the like button and consider subscribing to the Prevailing Technology channel. It really helps promote our content. Maybe also send the video to a friend who enjoys math puzzles. If you didn't like this video, please feel free to use it to torment your enemies. Reminder, the links are in the show notes below, and be sure also to check out Veritasium's fun video 37, Why is this number everywhere? Thank you for watching.